Okay, these are the problems for these lessons. There are 10 problems. Let's go to the first one. The first one is say, given capital F of x, the antiderivative of the function 4t minus 7. What is the antiderivative of the function between, what is capital F of x between 0 and x for the particular case that x equal to? For the particular x of a case when x equal to, f of 2 when x equal to is the integral from 0 to 2 of 4t minus 7. The antiderivative of 4t minus 7 is 4t squared divided by 2 minus 7t between 0 and 2. And if you make the calculation, will be minus 6. If you do the same thing for x equal 5, f of 5 that represent the area below the curve 4t minus 7 between 0 and 5. The area f of 5 will be the integral from 0 to 5 of 4t minus 7 will be, if you make the calculation, will be 15. And you do the same for x equal 8. And what is for 0 to x? Well, for 0 to x will be the integral from x equal x, f of x is the integral of 4t minus 7 ddt. And the integral will be 4t squared divided by 2, 2t squared minus 7t. Evaluated between t equals 0 and t equals x will be 2x squared minus 7x. So this is the function f of x. And this function takes the value of f of 2 equal minus 6. I have calculated here. And f of 5 equal 15. Plugging the 5 here, and it will be 5 squared 25, 25 by 2, 50. 50 minus 7 by 5 is 35, it will be 15. 50 minus 15, it will be 15 minus 35 will be 15. So what it means, this problem? It means that the f of t is this rectilinear line, is the rectilinear line 4t minus 7. 4t minus 7 is the rectilinear line that do like this. Sorry, it's not this rectilinear line. When t equals 0 is minus 7, so it's this rectilinear line with a slope 4. The f of x, the one that is the antiderivative, is a function, the f of x is a function that I can plug it. When x equals 0 is 0. When x equals 2 is minus 6. When x equals 5, 2, 4, maybe 5, is 15. Maybe here, 15. And when x equals 8, 5, 6, 7, and 8, when x equals 8 is 72, very high, very, very, very high, 72. So maybe the function will do like this. Maybe, but it will not do like this. It will do something like this. The f of x will do something like this. Probably will do something like this, like a parabola. Like this will do. And indeed, it's 2x squared. 2x squared minus 7x. They'll do like this. Okay, this is the f of x. Let's do the next problem. The next problem, what it say is, let f of x equal the integral from 2 to x of minus 2 divided by dq. Evaluate f at the point x equal 2 and x equal 5 and x equal 8. Well, f of 2 is 0 because the integral from 2 to 2 is 0. No question. f of 5 is the integral from 2 to 5 of minus 2 divided by t cubed. If you make the calculation, it will be, I don't know, I didn't do it, you do it. F of 5 is the same thing. Is the integral of minus 2 divided by t cubed. The integral is t minus 3, t minus 3, t minus, yes, is 1 divided by t squared between t, well, it will be 3 divided by 75. And f of 8 will be evaluated between 2 and 8 and will be minus 15 divided by 64. Perfect. So I have evaluated f of x but at different points. What is f of x? You can find f of x. Let's go to find f of x. The integral, the f of x is the integral from 2 to x of minus 2 divided by t cubed ddt, or the integral from 2 to x of minus 2t minus 3 ddt, or the integral minus 2 by the integral t minus 3 plus 1 is minus 2 divided by minus 2. So this will cancel. So evaluate between 2 and x. 2 and x. So the minus 2 will cancel and will be equal 1 divided by t squared evaluated between 2 and x. So will be 1 divided by x squared minus 1 divided by 4. So the f of x is equal 1 divided by x squared minus 1 4. So f of 2, 1 divided by 4 minus 1 divided by 4, 0. F of what? 5? Let's go to 5. Let me see what I found. F of 8. F of 8. F of 8 will be 1 divided by 8 squared minus 1 divided by 4, which is the same that 1 divided by 64 minus 1 4, which is the same like like what? Like 4 minus 64 divided by 64 multiplied by 4, or minus what? According to this, is 1 divided f of 8 is minus 15 divided by 64. 15 divided by minus 64, yes? Let's go to check. Yes, yes, it should be. Okay. So now we are going to solve this problem. Let's say the integral from 0 to x of t plus 2 ddt. What is the integral of 0? What is the antiderivative of t plus 2? Is t squared divided by 2 plus 2t. t squared divided by 2, 2t. Evaluate between 0 and x means that f of x is this function, x squared plus divided by 2 plus 2x. Perfect. And the second part, we found f of x. So f of x is the antiderivative of the function t plus 2. The second part say illustrate the second fundamental theorem of calculus by differentiate the function. It says that the derivative of f respect to the x, which is the derivative of respect to the x of the integral from 0 to x of t plus 2 ddt, this is equal to x plus 2 is the function, is the integral. So the derivative and the integral are inverse operation. So let's go to do it. What is the derivative of f with respect to the x? Well, f of x is x squared divided by 2 plus 2x. What is the derivative? The derivative is x plus 2. Oh, yeah, it's x plus 2. It's done. It's the integral. So what it say exactly the second fundamental theorem of calculus? It say this, that the derivative respect to x of f of t of the integral from a to x of f of t dt is f of x. Perfect. So let's go to problem number 4. They give you f of x, capital F of x, like the integral of pi divided by 4 secant square of t dt. And it says find f as a function of x. So we need to make the integral. The integral of secant square of t dt is tangent of t. Why? Because the derivative of tangent of t is secant square of t. So the antiderivative of secant square of t is tangent of t. Why? Because the derivative of tangent of t is secant square of t. So because we found the antiderivative tangent of t, we can find f of x between pi divided by 4 and t equal x. Between t equal pi divided by 4 and t equal x, it will be tangent of x when t equal x will be converted in tangent of x. When t equal pi divided by 4 will be minus tangent pi divided by 4. But tangent of pi divided by 4 is tangent of 45 degrees, and the tangent of 45 degrees, or pi divided by 4, is 1. So f of x is tangent of x minus 1, and the derivative of f of x respect to x is the derivative of tangent of x minus 1. The tangent of x, the derivative, is the secant square of x. And the derivative of 1 is 0, so the derivative of f of x is secant square of x, that is here. So we have proven that given f of x equal the integral from a to x of f of t dt, if you make the derivative respect to the x of x, if you make the derivative respect to the x of the integral from a to x of f of t by t dt, you will obtain f of x. Interesting. Okay. Use the second fundamental theorem of calculus to find f prime of x if f of x is t cosine of t. This problem, it says use the second fundamental theorem of calculus. The second fundamental theorem of calculus says that the derivative respect to the x, or the derivative respect to the x from the integral from a of x of f of t dt, this is, you don't have to calculate, this is f of x. You don't have to calculate, this is done. So I have f of x, like the integral from 0 to x of t cosine of t dt. Who will be the derivative of x respect to the x will be x cosine of x. And the problem is done. Okay, now let's go to the next problem. The problem is say the same thing. Given f of x, what is the derivative of f of x? The derivative respect to the x of this expression is the integral. So given f of x equal the integral from 1 to x of the 4 root of t dt. Maybe it's a function that is difficult to integrate, but the derivative of x respect to the x, this is the derivative respect to the x of the integral from 1 to x of this 4 root of t dt. This is equal, you don't have to calculate anything. This is equal to the 4 root of x. Okay? That's done. Now we use the same technique here to calculate the f prime of x if f of x is the integral from x to 2. Now, this is not how we have the second fundamental theorem. The second fundamental theorem say from a to x of f of t d dt, this is f of x. And this is not written like this form. So I have to write it in this form. Equal, this is equal minus the integral from 2 to x of t cubed d dt. Now I can apply the second fundamental theorem. The second fundamental theorem say that if f of x is equal minus the integral from 2 to x of t cubed d dt, the derivative of x respect to the x, the derivative respect to the x of the integral of f of x to x of t cubed d dt, this is equal to the integral x cubed with a minus sign, minus x cubed. Okay, this minus sign. So the problem is solved. Now, this problem is a little bit different. It's say, if I give you f of x, what is f prime of x? But see carefully, it doesn't give you from 0 to x. It gives you from 0 to sine of x. And the second fundamental theorem of calculus is written like this. F of x is the integral from a to x of f of t d dt. And what it says that the derivative of x respect to the x, or the derivative respect to the x of the integral from a to x of f of t d dt, this is equal f of x. But this is not written in this form. It's not written from a will be 0, but x is not x, is sine of x. So it means that we need to write this expression like this. F of u will be the integral from a to u of f of t d dt. And now we can say the derivative of x respect to u, or the derivative respect to u of the integral from a to u of f of t d dt, this is the integral. And the integral will be f of u. So now we need to find, so the u will be the sine of x. So this is u of x. And now we have to apply the chain rule. The chain rule, because they asked me for the f prime of x, the derivative of f respect to x. But I will find the derivative of x respect to u. I will find the derivative of x respect to u, which is the integral f of u. But the derivative of x respect to x will be the derivative of x respect to the u multiplied by the derivative of u respect to the x. So name u of x like sine of x. So f of u will be the integral from 0 to u of a square root of t d dt. And the derivative of a respect to the u, the derivative respect to the u of the integral from 0 to u of a square root of t d dt, this will be the integral, right, a square root of u. So f prime of x is the derivative of f respect to the u by the derivative of u respect to the x. The derivative of x respect to the u is a square root of u. And the derivative of u respect to the x, because u of x is sine of x, the derivative of u respect to the x is cosine of x. So the answer will be a square root of x multiplied by cosine of x. But u is sine of x, so it will be a square root of sine of x multiplied by cosine of x. You need to practice some more problem like this. So pay attention what I have done. What I have done is they ask you by the derivative of x respect to x. But the chain rules say that the derivative of x respect to x is the derivative of x respect to the u by the derivative of u respect to the x. What I can find here is this term, the derivative of x respect to the u, if I name sine of x like u. So f of u will be a by u, and this continues to be the problem. Okay. Now imagine that they ask this problem. They give you f of x in the form, the integral from x to x plus 2. So imagine the a is here, this is the function, this is the integral. Well, the integral is a rectilinear line, I don't matter. This is the function, 4t plus 1, that is not this shape, but it's because it's a rectilinear line. This is the point A, this is the point x, and this is a point that is x plus 2, so it's more to the right. And the integral from x to x plus 2 is this area. Now, if we have to apply the second fundamental theorem of calculus, this is not in the form the integral from a to x. This is in the form of the integral from x to x plus 2. But we need to convert it to the form a from a to x. So this area, the way to convert it to make the argument like this. This area is the area between a and x plus 2 minus the area between a and x. The area between a and x is this one. The area between a and x plus 2 is all the area. And if I subtract the area from a to x, I will have the area from x, between x and x plus 2. So I do this. The area from x to x plus 2 is the area from a to x plus 2. A could be any number. Minus the area from a to x of the same function. Now I can apply the fundamental theorem of calculus. The fundamental theorem of calculus say that the derivative of the function f respect to x is equal to the integral f of x. So f of x will be 4x plus 2 plus 1 minus the derivative of x respect to the x. The derivative of this is the integral f of x. Evaluate at the point x will be 4x plus 1. So if I make a little bit of algebra, will be 4x plus 8 plus 1, 9, 4x plus 9, minus 4x minus 1, will be 9 minus 1, will be 8. And the problem, this problem is a physics problem. You will use in physics courses, and it will say like this. Given the graph of b of t, so it's the velocity as the time t elapses. And the function that they give you is t squared minus t minus 12. Find the displacement between 1 and 5. And find the total distance traveled. Well, let's go to focus on the displacement. That is more interesting. So, the function, the velocity v of t is here. This is the graph, is t squared minus t minus 12. So it means, and it say between 1 and 5, so 1 is almost, let's say here, so the velocity is negative, and the velocity becomes less negative and less negative. The velocity, and here the velocity is 0, and after that the velocity becomes positive. What it means that the velocity is negative? It means that the object is moving in the minus x direction. And the amount of velocity is very big at t equal 1. After that, the velocity is going to the left. The object in the x-axis, this is the x-axis, the object is moving to the left. And when t equal 1, is moving with a big velocity. When t equal 2, the object is still moving to the left with a smaller velocity, but also to the left. And when t equal, let me see what time here, t equal 4, the velocity is 0. And when t equal a little bit more than the time t equal 4, the velocity is positive. So at t equal 4, the velocity is 0, and after that, the object will move to the right, and the velocity will become positive. So the relation between the velocity and the position is that the velocity is the derivative of s respect to the t. The velocity, if you make the graph of position s, is the position respect to the time t, the velocity is the slope of the graph. So, for example, imagine that this is the graph. So the position is like this, and the velocity is the slope. The velocity is delta x or delta s divided by d dt. The velocity at this point is the slope of the graph of position. So what this problem is saying, given the velocity, can you find the s? Can you find the antiderivative? Can you find the function s whose derivative is the velocity? Of course, we are experts to find this. V of t is the derivative of s respect to the t. So d ds is v of t by d dt. So if I make the integral on one side, it will be s minus s0. S minus s0 is the displacement. The displacement is the final position minus the initial position. This is the displacement. So making the integral on this side and making the integral on the other side, from t equal 1 to t equal 5, it will be the displacement s minus s0, displacement will be the integral from t squared minus t minus 12 d dt. If you make the integral, will be t cubed minus t squared minus 12t. You know how to do it from t equal 1 and t equal 5. And if you make the algebra, will be minus 56 divided by 3. What it means minus 56 divided by 3? It means that the displacement, the s minus s0, has been from the initial position, has been moved to the left, 56 divided by 3, an amount of 56 divided by 3, but to the left. What it means that? This is the area below the curve. And what it says that the area below the curve between t equal 1, which is here, and t equal 5, which is more or less here, the area is negative because there are more area below the curve that, let's say, t equal 5. The area is negative because there are more area below the curve. And what it says that the area below the graph of v of t is the displacement of the body. So in this case, the displacement is negative because there are more area that is negative. And the distance travel is another problem that I will touch later.